boiler cast can only record audio, and actually it didn't even work last week. Since this class, we have a lot of visual information, so we are experimenting recording using a camcorder. And I hope that will not bring too much trouble for you.
No.
Okay?
No.
After you say that, maybe you can see next. So just leave it there.
Can you turn off the light?
Can you turn off the light?
Maybe it's better.
Is it better?
It's better.
How about other? Is that okay for everybody? Okay. So a few people had a problem. They tried to install VirtualBox in a minute. How many of you had that problem? One. I think I told you yesterday. I tried to use 32-bit. Did that work?
Yep.
Okay. So one solution is you go to download, and then here you say download, and here instead of using 64-bit, you use 32-bit ISO file, and for some people that solves the problem. Okay. Before I start, any questions about anything? Yes, please.
If we SSH into the school's Linux computers and then run the tester that way, would that give us an accurate? You said you grade on those computers.
Yes.
Would it give you accurate results on those computers?
Yes. And that's our intention, unless we have a bug. But if we find a bug, then that's not your fault. But that's our intention. Yes, you should use school computer to run the tester. Yes.
Does Valgrind work in VirtualBox? Because I know you said there would be constraints Intel processors and stuff.
I have run Valgrind in VirtualBox since working.
Okay.
For Valgrind and many other things, you need to be aware is the following. Okay, I need to talk about logic. And for logic, we are going to spend some time about logic in this class. Is the following. So, before I ask this question about programming, let me ask the following question. Let's just say you agree on the following definition. If the temperature is below 40 degrees F, okay? If it's below 40 degrees F, and you agree with this definition, means it is cold, okay? Can we first agree on the definition here? Okay, so if we agree on this definition, and you see it is snowing, does mean it is cold. Is that a valid statement?
No.
Why not?
Because it could be snowing when it's higher than 40.
Okay, can you be higher than 40 degrees when it's snowing?
Not really.
You will be melted.
I mean,
Okay, 50 degrees, how's that? Okay, 50 degrees. I don't think you can have snow when the temperature is above 50 degrees. Is that okay? So if you see snowing, does that mean it is cold? Any objection? You agree? Yes. Okay, so the next question is, if you do not see snowing, does that mean it is cold?
Could be. I said it could be.
It could be, and it
could not be.
could be not.
Yeah.
So this relationship is invalid. No. You cannot come from left to right. Okay? So if it is not snowing, does that mean it is warm or hot? Can you make that statement? No. Why? It could be cold. Like yesterday, it was not snowing, and it's not from the sky, right? There was snow on the ground. It was not snowing, but it was still below freezing yesterday. Okay, why do I talk about this? You need to understand logic, because in this class, because computer programs operate based on logic, called if statement. So if A is true, then B is true. Suppose we agree on this statement. Okay? Give you an example. If x is 0, I will make y 0. So that's what you see in your program. Okay. So if A is true means if x is 0, I'm going to make y 0. So B is true. B in this case means y is 0. So can I say the following statement? If x is not 0, then y must be 0. Can I make that statement? No. If x is not 0, this if statement is not true, therefore you have no idea about y. So this is wrong, right? Now how about if x is not 0, then y must not be 0. Is that statement true? No. Why?
Because it could have been initialized to 0 or...
If y could be initialized to 0, so it's also wrong. Because you may have this case, y equal to 0, x equal to 1. Then you say, if x is 0, y is 0. Since x is not 0, you don't enter the if statement, but y is already 0. So if x is not 0, you don't know whether y can be 0 or not. Now this is important because I've seen some students, they get confused about the logic relationship. So somewhere they see here, they see y is 0, and then they think x should be 0. Somehow they think that. That is wrong. Because y could be 0 already. Okay. Any questions about this? Now, what was your question about Velcro? Or what was the question about Velcro? Okay. So why is this important? When Velcro tells you there's a problem, then there's a problem. When Velcro doesn't tell you there's a problem, there may or may not be a problem. Maybe it doesn't detect. When there's a problem, Velcro may or may not tell you there's a problem. So, how to deal with this? Don't rely on testing. Testing is not a very good way to know whether your program is correct or not. Yes, you do need to use testing. What it means is, if tests fail, you do know there's a problem, that's for sure. If tests succeed, you don't know. This is very, very important because many students somehow think passing test means the program is correct. That thinking is wrong. Now, how can you do? The best thing to do is to read your program very carefully. You cannot rely on testing to know your program is correct. There are many other things I'll tell you, some skills, some strategies to make the programs correct. But the important concept here is you should not rely on testing. Okay, any questions? So going back to here, snow, it's important to understand the difference here. If it's not snowing, it may be cold, it may be warm. If it's not snowing, if it is cold, also, if this is cold, it's possible it is not snowing, right? That is possible. Like yesterday, right? It was not snowing. It was almost sunny yesterday. but you are still cold. And then here we define cold is below 50 degree F. Suppose we agree on that definition. Okay. Any questions? All right, before I move on, I want to remind you there were 2 handouts I gave last week. If you don't have the copy, please come over after class to get a copy. You should glance through. I will call them the dictionary. Means you don't have to memorize them, but you should glance through to get the idea what commands there may be, because they will be very, very useful for you for this class and for many other classes as well. Okay. I hope the class is interactive, because there have been numerous studies showing that if professors just talk, students fall into sleep. So I hope the class is interactive. Before I continue the lecture, I'm going to ask the following question. How many of you bought a computer in the last 6 months? Oh, nobody. How about a year, within a year? Okay, how do you choose your computer? How do you decide which computer to buy?
I saw a new computer coming out, so I bought it. I think it should.
How do you describe the computer you bought?
Lenovo.
Okay, that's a brand.
And you can choose everything inside. So I choose all of them to be high. I don't know how to describe that.
Okay, do you buy a computer? Do you also raise your hand?
Like 2 years ago.
Okay, so how do you describe your computer? If somebody asks you, what kind of computer do you buy, what will you answer? How will you answer it?
It's silver, and it's an ultrabook.
Okay, and
I don't know.
some more technical terms? Can somebody else help? Okay.
I bought a desktop just based on my see what what functions I need, how fast I need.
Okay, how to describe fast?
Clock time.
Clock?
Clock, CPU.
Okay, CPU clock.
Or GPU clock.
Okay, anything else? How do you describe a computer?
RAM.
RAM? How much memory do you have?
I have 8 gigabytes.
8 gigabyte.
Yeah.
Do you know what that means? Do you know 8 gigabyte of memory? Do you know what that means? What does that mean?
That means there's the computer operates on 3 different memories. There's CPU memory, then there comes random access memory, and then there comes the hard disk. So
Okay.
to access the information faster, there exists such a memory. I mean, it's relatively small compared to hard disk because it's a kind of solid state. It's like a CPU itself, the RAM, and the CPU, when it needs very quick information, when it's processing, when it's doing something, it gets the information from the RAM rather than getting it from the hard disk, because it would be very slow
Okay,
to get
RAM is much faster than disk. How much is your disk? Do you know?
At 2 TB.
Wow, that's pretty okay. All right. Random access memory, and compared to random access memory, you can imagine there's sequential, right? So let's talk a little bit more about memory. Do you know what does 8 gigabyte mean?
Yes.
You talk too much. Somebody else. Don't be mad. Somebody else. Okay, you are laughing. What does 8 gigabyte memory mean?
It just has to do with how many physical memory locations there are to store information.
How much space you have. Okay. So B means byte. 1 byte means 8 bits. 1 bit means enough information to store either 0 or 1. And this means it's binary. Either 0 or 1 means binary. We call it binary logic. We also call it Boolean logic, because a scientist or mathematician or develop the mathematics behind binary logic. I expect people to take notes. Watching is not learning. You need this information for many other courses, like such as 270 or 362 and so on. So let's talk about memory. What does it mean by 8 gigabit or 8 gigabyte? When you have a memory, basically 1 bit in the computer memory is organized in the following way. It's called address and variable inside your computer memory. Address is determined by hardware and by operating system. It's managed by operating system such as Linux, Windows, and so on, plus hardware. We sometimes write this. This means hardware. And variable is managed by your computer program or software. Sometimes you see people write SW means software. When you say 8 gigabyte memory, it means the following. We'll organize it at byte. So here you have a byte and you have an address. Address will go from 0 1, 2, 3, and then eventually go to 8 billion minus 1 because we start with 0. Any questions so far? Computer memory is always organized by address and the variable. There's no exception. And as a programmer, you write program, you have no control of the address. And there's no exception, unless you are writing operating system. And you are not for this course. If you take 469, you will be able to 469. ECE264 is operating system. For 264, you're not writing operating system, so the only thing you can control will be variable. So let me make an analogy here to explain to you what it means by you are not allowed to choose address. How many of you live in dormitory? Do you choose where you live? No, the university assigns. Right? Think about your address. Your dormitory address is given by the university. Right? So address you cannot choose. There's no exception in 264. You can never choose address, period. It's important to understand that. So you can never say, I want to store a variable for some reason. I want to store variable at address 2000 and I want to store 5 there. That doesn't work. Operating system will stop you. Just like the university give you a particular room and you say, I don't like that, I'm going to go to another room. And then if you try to enter a room, whoever lives there will call Purdue police. Right? Don't try that. Okay. So you cannot choose address. That's a very important concept here. Any questions so far? So what does this mean? So I'm going to make an analogy here explaining address and a variable. So you can think of this, let's say we are thinking about a street, let's say Main Street. You have people living on the main street. You can have address. You have variable. Let's consider variable will be the name of the family living there. So you may have somebody living first Main Street. The family will be like Smith. And another family living on the other side of the street, maybe the family name will be called Black. And another family living somewhere and maybe called Brown. I think there's popular names, right? Or another family, maybe Johnson. So you have address and a variable. The variable will be the name, the last name of the family living at that street, at that house. In a computer, you may have address, let's say 001, and still a variable will be 24. And another address may be, let's say, -9. And another address somewhere maybe 14, something like that. In 264, being able to understand how memory works and how to use memory is the fundamental part of a 264. Any questions so far? Well, if there is no question, I'm going to ask you questions to review what you have learned in CS159. Okay. So imagine the following situation. I have a function, not for the time being, don't worry about function return or function argument. Just a function f1, it does something. And function f2, it does something, then here it calls f1. So I'm going to mark this function into different parts. I call it, this doesn't work, no ink. It's called part 1. And then it's called part 2. And I call it part 3. Inside F1, part 3. Suppose I run F2. What would be the order of these 3 parts? First question is, do we execute the 3 parts? Yes. Okay. The second question is, we have 1, 2, 3. What's the order of 1, 2, 3? Somebody in the back, the one with the green shirt. Yes. 1, 3, 2. You want to raise your hand? Do you agree? Yes. Okay. Is there any question about this? The order of execution will be 1, 3, 2. Okay. Everybody agree? Yes.
Why doesn't it come 3 first? 3, 1, 3, 2. Like the.
I call function f2.
So, you call f2.
Yes.
Okay.
So suppose my main function. Sorry, maybe I didn't make the question clear. Is that clear? Okay. So main function calls function f2. So function f2 will go to part 1. Then we'll call function f1. F1 will call part 3. And then after function f1 finishes, you'll go to part 2. Any questions about this? Okay. Now let's consider something a little bit more complicated. So I have function f1. It is clear enough. Can I use this ink? This pen? No. Okay. So let me call it part. Instead of using 1, 2, 3, I'm going to use A, B, C because the 1, 2, 3 seems confusing. Part 2, I have part B, I call F1, I call part C, and F3, I call part D, call F2, and E, called F1, F. And in my main function, I'm going to call F3. So the question is, what's the order of A, B, C, D, E, F?
D.
Hold on. Does everybody understand the question? You need to write A, B, C, D, E, F. Some of them may repeat. Some of them may not show up. Does everybody understand the question? Okay. Write down your answer and show to your neighbor. You have 1 minute. Go. Write down your answer and show to your neighbor. You have an answer?
Yep.
Yeah, okay.
Yeah, I guess.
You have your answer? Show to you. You have your answer? Okay. Compare your answer with your neighbor, see whether you get the same answer. What do you think? You got your answer? Dr. Schiller? Come over. Okay. What's your answer? Okay. So you will be D, B, A, C, E, H, F. Is that right? Do you agree?
Yes.
Thank you. You agree? Yeah. Okay. So we'll call F3 first, we come to D, so there's no problem. We call F2, we go to B. And B calls F1, so we go to A. After F1 finishes, we go to C. Right? So we're done with F2, so you go to E. Then E calls F1, so you go to A again. And after A, you go to F. Any questions about this? It is familiar to you for CS139? Do you know how computers know the order? Do you know how computer knows the order?
The commands are stored in memory.
Okay.
In order that they execute.
In the order they execute. Can anybody say more?
The call stack.
Call stack. Okay, we're going to introduce the concept called call stack. How many of you have learned in this CS139? How do you know call stack?
You talked about it the other day, so I was good.
Okay. Who else knows call stack? Okay, one more. All right. So before I talk about call stack, I'm going to talk about the concept of stack. Stack means first in, last out. So I'm going to talk about fashion. Or maybe not fashion, just daily, everyday life. When you wear shoes and when you wear socks, what do you put on first? You put on socks first, right? Then you put on shoes. I guess anybody do the other way? Does the other way? No, okay. When you take off, what do you take off first? Shoes. So you put on. That's an example of stack, right? How do we think about stack? Conventionally, stack is done by the following way. We'll draw a stack this way. We'll put this here, we remove this on the top. So think about your shoes and the socks. You put socks, then you put on shoes. That's how you put in or put out. When you remove socks and remove shoes before you remove socks. When you put this in, this is called push. When you remove this, it's called pop. So push means put something new on top. And pop means remove the top. That's what stack means. Okay, any question about this so far? Okay, so if we understand stack, let me talk about what's call stack. Call stack, call means function call. Call stack is the way computer manages function call. Maybe I should say function calls. Whenever you call a function, when a function is called, the line, in other words, the statement, I assume you don't write two things on the same line. The statement after this call is stored in the call stack. So if you come here, and suppose I write down line numbers here, let's say this is line, I'm going to use number, non-continuous number. Suppose this is line 10, this is line 20, and I have some function code there. Let's say this is line 30, 40, 50, 60. Suppose these are some line numbers. You can imagine you may have several lines there, right? And so on. And then here, let's say this is line 70, and then I have something more. After that, I have 80. So for each part of a program, every line, I have a line number. Then when main function calls F3, based on this rule, when a function is called, the line after this call is stored in the call stack. So the call stack will store 80. What does that mean? It means where the program should continue. After function F3 finishes, the program should continue from line 80. So I go to F3, F3, execute line 40, part D, so we see D here. Then it's going to call function F2. Whenever there's a function call, the line after the function call is put in the stack. So F2, I'm going to put line 50 in the call stack. The line after the function call. Because you want to know where the program will continue, right? If you store the line of the function call, in this case, let's say the line is 45, and you store 45, means you are going to call the function again. Does that make sense? So you will store the line after the function call. Any questions so far?
No.
Okay.
Can you please pull the paper?
Okay, this way.
Yeah.
So first rule you need to remember is whenever there is a function call, the line after the function call is stored in the call stack. Here I assume you do one thing per line. You don't write a line with many things. I just assume function call and there's nothing after that line. So whatever you need to do will be the next line. Okay. What I mean is you don't write function code like this, F1 in the same line, F2, F3. You don't write that. You break that into multiple lines. That's what I mean. So you call function 2, put 50 there. You go to function 2. And function 2, you'll execute B, so you can see B here. Then you call function 1. And you call function 1, therefore you put line 30 in the call stack. Because the line after function calling function 1 will be 30. You execute function 1, so you get A here. After function 1 finishes, you look at your call stack. So this is the first part. I know it's getting messy. I'm going to clean up in a moment. Okay, when a function call is called, the line after this call is stored in the call stack. When the function finishes, the top of the call stack is used to determine where the program continues. And the stack is pop. Remember, pop means you remove things from the top. So pop, you remove the top. Maybe I should zoom out a little bit. Every time you call a function, the line after this function call is pushed to a stack. Every time a function finishes, where should the program continue? That's determined by what is in the call stack. Since we remember the line after the function call, the program will continue from that line. And that top of the stack is popped. So these are the two rules. The good thing about these two rules is there is no exception. Yes, please.
Can you make like multiple instances of the stack? Like have 2 different stacks?
There's only one call stack. And you don't handle the call stack, it's handled by the compiler.
No, I mean the regular stack you just use to put data on, not the call stack.
You have no control of the call stack. Call stack is managed by compiler and operating system. Did I answer your question?
No, I don't know.
What? Can you say your question again?
Because in C# you can't make multiple stacks.
That's not call stack. You can create a stack to store data.
Yeah, that was my question. Can you make multiple?
Okay. So let me see whether I understand your question. You can create a piece. You can manage a piece of memory, and that follows this rule: first in, last out, or last in, first out. That would be called the stack. But that's not call stack. You know what I mean?
Yeah.
Call stack is managed by compiler and operating system, and you have no control at all. You cannot say what should be on the call stack. You have no control. You cannot say what should be pushed, what should be popped. You have no control. Every time you call a function, the line after the function call is always pushed to the top of call stack. You have no control. You cannot say, I don't want that. That's call stack. I think what you are saying is, can you create something called a stack? Yes, you can create a stack, but that's not call stack. Does that answer your question? Okay. Yes, please.
I could write code without using another line for each comment, right? So how does it actually store the next line in the call stack? You know
What do you mean without a line?
Yeah, well, I can just write comment after comment without creating a new line.
You can write comment, yes.
Yeah.
So if there's a comment, then you can. So if you write, let me use another piece of paper. So you write something that say a equal to 5, then you start writing comment, right?
Yeah.
You still have line number, don't you?
Okay.
So for that case, these are not considered. So if you, let's say, this line 10, this line 20, and you have a function call here, and you comment, and then this, let's say this is the line 40, suppose you write a lot of comment, and here is useful statement. In that case, you'll remember 40 instead of 21. Does that answer your question? You can think of 21 as a comment, so it doesn't really do anything. You can put 21 there, but the compiler will just jump directly to 40. Since in the middle, they have no effect on execution. Does that answer your question? Another question? Any other question?
So in the case that he gave, will 21 go to call stack or will 40 go to
40 goes to call stack. But even if 21 goes to call stack, that doesn't make difference because there's nothing to execute from 21 to 40, so it doesn't make difference. Yes?
Is main always on the bottom of the call stack, or is it even on?
Main is at the bottom of the call stack, yes. I was not planning to talk about that yet, but since you asked, is at the bottom of the call stack. Thursday last week, I showed you how to see call stack. Does anybody in GDB? Does anybody remember how to see call stack in GDB? Which command? BT. Backtrace shows a call stack. You'll use this command a lot when you debug your program. Of course, some people don't write program with bugs, but just in case you have a bug, you will use this command. Shows in a stack. This stack is the call stack. Okay. Any other question? So let's go back to this program and see how we can understand the execution order of this program. So we have a D, B, A, F1. Oh, too much. F1 here. After F1 finishes, you will go to line 30, that's in a call stack. So you will execute C. And this one is pop. After C, function F2 finishes, you look at the call stack, it says 50, I go to 50, so the program will execute E. Alright? And since F2 finishes, this gets popped. So you execute F2 and execute E, then you call function F1. Every time you call a function, the line after the function call will be pushed to a call stack. So now you put 60 there. Remember, 50 is already removed. So you go to function F1, you call A again. Then function F1 finishes. So you look at the call stack, you have 60. So you come here and execute, and 60 gets popped. You execute F. And after function F3 finishes, you look at the call stack, and you continue from here. Continue the main function. So let me remind you what are the rules. When a function is called, the line after the call, this call is stored in the call stack. That means push. So I would write push here. And when the function finishes, the top of the call stack is used to determine where the program continues. And the stack's pop means the top one is removed from the call stack. Yes, please.
What happens to the call stack if your program is multi-threaded or hyper-threaded? I forgot the difference.
Multi-thread. First, in ECE264, if we have time, we'll talk about thread. If you have multi-thread program, each thread has its own call stack. You are very far advanced. Okay, that's good. Any other question? Did I answer your question? Okay. Any other question? Good thing about this rule is there's no exception. If you compare C, how many of you have learned second language? Spanish, French, Italian? Which language do you learn?
Turkish, Russian, English.
Wow. Are there exceptions in the language?
Yes.
Okay. How about someone else? Who learned French? What language do you learn? Okay. Are there rules and exceptions? Okay. The good thing about C language is there are rules and there are no exceptions. So if you know several languages, you should say C is easier. Oh, now I'm going to talk about a word mentioned in this manual or quick reference. Frame. F-R-A-M-E. What does that mean? Every time a function is called, the line after this function call is pushed to the call stack is called a frame. Oh, sorry. Take care of me. So let me rewrite this rule using the terminology here. Every time a function is called, a new frame is pushed to the call stack. What information does the frame have?
The next statement after the call
Yes,
function.
the frame includes the line after this function call. Or the next statement, basically determine what the program should do after the function finishes. The corresponding of this is every time a function finishes the top frame. Actually, I don't need to use the word top. It's pop, because pop always takes the top one. Any questions? I'm going to show you an example what I showed last week that I want to show you again because it's a way to look at this. Everybody done with this? I'm going to switch to my computer. So this is the assignment, and I'm going to run GDB. For you to learn debugging, again, watching is not learning. You have to use it. You have to practice using it, then you know how to use it. I can show you again. You're not going to know how to use it. Interesting is every semester I show students how to use GDB, and at the end of the semester, always a few students says, Professor Lu never showed us how to use GDB. Okay, so look at the people around you. You will be the witness showing, I'm going to show you how to use GDB. So if somebody says, I don't show you how to use GDB, please tell them, I have shown you. Okay. So maybe let me take one step back. First, how do I get here? I have the program. I have the C file. So if you read README tells you how to convert the C file to, the C files are files people can read.
Can I ask a question?
Yes, please.
If you connect to ECN computers remotely, okay, let's say using Linux, is it still gonna open a GUI interface like this, or is it gonna open Emacs interface on the in the terminal?
Okay, are you using, what machine do you use from? What's your local, the machine you are typing?
I'm using Windows.
Okay,
I have Linux as well, but
so his
usually-
question is, if you have your local machine, that's a machine you are typing, okay? And you connect to an ECN computer, do you get graphical user interface? Is that your question?
yeah, if
Okay. You get graphical user interface. Is okay. So if your local machine is Linux, you need to use SSH in a terminal, and you need to use -Y. And then your account at ECE Linux, and give a
That's-
number, and so on. Let's say
that's to connect to the ECN, right?
yes, 25 ECN.Purdue.edu. You need to use -Y. That will allow graphical user interface to come back if you are using Linux. If you use Windows, you need to start an X server. How to do that? There are multiple ways to do it. To do this,
Secure CRT is that.
secure CRT is not enough. Secure CRT does not allow you to. Secure CRT, you can only type through a window. The graphical user interface will not come back. You have to start an X server on Windows. How to do that? There are multiple ways. You can search online. One way is to use Segwit.
X server, you mean like ECN
On Windows.
server?
You need to start an X server in your Windows. That way, you can have a window coming back to your local machine. Otherwise, secure CRT, that window is the only window you can use.
Okay.
Yes?
Is there any disadvantage if I write my code on my own machine, then copy it to the ECN computer and compile it there?
Okay, so
Using version control becomes harder.
yeah, that makes things harder.
Okay.
For some students like to do this, but I discourage because it just makes things hard.
Okay.
I think you should have a Linux machine in front of you. That
Yeah,
makes
well,
things easier.
If I have on my own computer, I have Linux.
Yes.
So, but you said it might cause some problems because it might not really compile or something if I use my own machine, and then because the grading happens on the ECN computer, right?
Yes.
So there might be some problems if
So one thing you can do is, after you are very certain your program works,
yeah.
you put into ECN and test it just before you submit.
Okay.
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 Now, one question come up is, how do you move files around? Right? If you want to move files between your local machine to ECN machine, in Windows, you can use secure file transfer. You can download this by going to Add tab, software download. Secure file transfer. In Linux, you use secure copy, SCP. That's a command. If you look at the Linux guide here, there should be a command called copy. CP means copy. Secure copy is a little bit different. Similar, but a little bit different. Let me take out a piece of paper. Maybe let me show you. Yes, your
The
question.
start and X server, the X is you mean like any variable, or you mean like you have to
No,
when I
X server is a program.
Oh, is a
X-
program?
Yes,
Okay.
X means X window.
Okay.
X window is a program I believe was created by MIT in the 80s. X window is a program. It's not X means anything. X is a specific name for program.
Okay.
So if you want to see how to start X server on Windows, you need to search start X server on Windows.
Thank you.
Thank you for asking. Now let me show you. So I discourage you to use Windows because that creates a lot of trouble. So assume you have a Linux in front of you. I'm going to show you how I can move files around. So this is a, oh, you don't see it. This is the machine in front of me. This laptop. So what I'm going to do, okay, so suppose everybody knows how to go to terminal. What you're going to do is you type terminal here and you can click. I'm using Ubuntu. If you use Red Hat, you should go to the top, say System and Terminal, something like that. So you can have terminal, and you can click and drag this to the side, and the terminal will show up here. So you don't have to do that every time. You can just click. That makes it easier. So how do I move files around? So I'm going to create another terminal. Just okay. And I'm going to first I will say SSH -y. -y allows the user interface to come back.
Is the software needs to be installed on your computer for the GUI to come back?
SSH client should already be installed when you install Linux. SSH
No,
client,
no, no.
this program.
No, I'm not asking. For example, you want to run Emacs. on
Emacs,
the-
you need to install Emacs.
Oh, so I have to install Emacs on my local computer when I try to get a GUI from the remote
No,
server.
if you want to get a GUI from
Remote.
remote, you don't have to install Linux. Emacs.
Okay, that's what I was.
Okay. So suppose I will say that's my account. A common mistake is ECE Linux. It's not ECN Linux. ECE Linux. And then another thing is you have to put the ECN w.edu. And here is ECN, not ECE. Don't ask me why. That's just the way it is. If you have your program, you'll ask you for password. You can create something called SSH key, and I have that here apparently.
So I can connect to any account without a password right now?
If you set up SSH key. If you set up SSH key, you don't have to use password. SSH key says, I know the two computers know each other. So if you create SSH key, you will not ask you for a password. And in fact, SSH key is arguably more secure than password. Because password, every time you need to type in, and somebody may watch you type in, if in a public place. SSH key, since you don't type in, it's more secure. But SSH key is between two computers. If you go to another computer, you need to set up SSH key again. So in this case, I set up SSH key, so I can connect there. Now suppose I have a file. Let me create clear, the command clear, just clear the screen. So I don't have a lot of stuff there. So suppose I create a directory called, let's say January 21. And I change to that directory. I think you need to take note on this one. Okay, first, SH is -y. Now the color, I set the color to be green on black. You can set color to whatever you like. So first you want to ask user interface. So if I type Emacs, now this ampersand here in terminal means I want to reuse the terminal. So if I don't type this one, you'll create Emacs. But this terminal is not useful. It's not usable anymore because currently I'm running Emacs. If you want to if you come to a terminal, you do whatever ls, it doesn't respond. Because currently the terminal is running Emacs. So suppose I quit, then it can respond. So one thing you can do is to put ampersand after. Now notice this ampersand is inside terminal. When we talk about C programs, the ampersand means completely different things. This is in terminal. Is it here? No, I guess not. When you put the ampersand after a command, means you will run the command, but you can still use the terminal. So if I type Emacs here, I get Emacs. This Emacs is from remote machine, and here I can still use the terminal. For example, ls. There's nothing here, but I can still use the terminal. Okay. Any questions so far? So I'm going to create a file. I'm just going to write something here. Okay, so I will say, I will create a file. Let's say, hello. Oh, I'm going to create a new file. This is an example. I'm going to save it. Save as. Okay, I say hello. So I save the file into hello, and if I do ls here, you can see the file called hello. And that's the file I have. This currently is in ECE264. It's not on my local machine. You have a question? Go ahead. Excuse me?
I'm just following along.
Okay. So I have a file in a remote machine, and now I need to move the file back to my local machine. Let's say I create, this is my local machine. I create a directory called the temp. Oh, do I already have temp? Okay, then maybe call the temp2. Now there's nothing here. I want to move the file from the remote machine here. You need to do the following. You need to know where the file is. So use the command pwd. Pwd means present working directory. Looks like it's not here.
It's there, it's there. So
It's
the
here.
file command. First.
Oh yes, show working directory. So if you look at this page, it's this one, pwd. Thank you. You need to know where you are. Yes.
So you already set up the SSH key with the Linux 31, or 31 just a number you pick?
Yes, I already set out SSH key between this machine and the machine in ECN.
So you can actually connect any machine right now? Or just
I can only connect to ECN machine, and I have to go use this particular machine. If I use this particular machine, connect to an ECN machine, I don't have to type password. Yes?
When you say EC Linux 01 or 2, does the SSH key connect you to any of those or just one of them?
I believe ECN set up so that all the ECN machine will be able to use the same SSH key. Okay, so this is the directory on a remote machine. Now I'm going to copy the file from a remote machine to my local machine. You need to know the directory. So I will say scp, my name, :/:, and that is followed by the directory. On Thursday, somebody asked me how to copy paste. In most Linux, you can copy using the left mouse button, left button. So I highlight this. And then to paste, I use the middle button. That way I don't have to type a lot of things. So this is where it comes from. The CP command is source and the destination. So this is the source. Destination, I use period. Period means the current directory. That means right here. So this will copy the file from ECE Linux 33. Actually 31, 33 is fine since SSH key, as I said, I think they all share. I copy to this directory, and it's copied. It doesn't ask me for password because I have an SSH key set up. So now I have the file here. Yes.
Will it still copy even if you're not connected to ECN computers at the moment?
Well, you not copy. Okay, you are saying if I get rid of this one, yes, but I need this one to know the path. I need to know the path. Okay. So if I disconnect right now, I can still copy. Does that answer the question?
But with the SSH key, right? Because
Yes. SSH key doesn't matter who you are connected or not. Just says if you have SSH key, but you want to connect, it doesn't ask you for password. That's what the key does. Any other questions? Yes, please.
Full stop after the hello.
I didn't hear you.
Did you put the full stop or?
The period?
Yeah.
The period, there's a space. The period means the current directory. Or if I want to say I want to change the name, I will say Tuesday.
if you put 2 dots, it goes to the back directory.
Yes,
right?
if you use dot means the previous directory, the directory above this one. Period means this directory. And I can also change to another file name. In this case, I call Tuesday. So the file will be stored called Tuesday. Copy is source destination. So if I put, let's say I put Tuesday
So
here,
right now, hello is in Tuesday?
I copy the file from remote to my local and I call it Tuesday in this command. I do not use period, I use Tuesday. Right,
Is
so now I
that
have
the
two
file
files.
name or is
Tuesday
that
is the file name.
Oh.
I call it Tuesday because I replace period. Period means the current location. But instead of calling stored in this, if you use period, the file name will not change. Now I change the file name to be called Tuesday.
Is it that Tuesday is a file, not directory?
It's a file name, yes.
Oh, I thought.
Now if I look at the remote side, I have only hello. Now I'm going to put Tuesday. Notice that I changed the order. I changed Tuesday as the source. And the destination, I can also change the destination. Let's say I call it 2014. So that is the path, home, and so on. That is the directory. And I say that the destination is going to call 2014. And I put enter here. And if I go to remote,
It's 31.
excuse me?
The first one is 31, the second one is 33. So
Yeah. I
It
mean,
should work.
it should matter.
It shouldn't matter. So did I do something wrong?
I think what you're saying contradicts right now. Because
I have too many files. Oh, it's just, oh, okay, I know why. 31 and 33 are two different machines. So it takes a bit time for 31 to know the file on 33. 31 and 33, all the ECM machines, if you log in, they all share the same files. But it takes a bit time to propagate between machines. So now you can see 2014.
the 2014 is the file that is called Tuesday on the local machine, right?
Correct. The local machine, the file is called Tuesday. I copy to this destination and call it 2014. Now I have that
So
file.
there's a space between the dash and the 2014.
There's no space.
There's no space?
There's no space. It's just the wrap around because the screen is not long enough. Another command you want to learn is history. So if you look at history, I guess this is not long enough. Well, you can see there's no space here.
I'm sorry, can I ask a question?
Please.
In the first one, you did SCP from your remote account. You copy the hello file, you put space, right?
Yes, there's
And then
space
you
after
call it
hello.
Tuesday. Is that correct?
You mean 27 or 29?
I think that
29, there's a space
20
here.
yeah, 29, yeah.
There's space here. Because you need to have source, space, destination.
In that 31, you didn't write, you only write,
There's a space between Tuesday and the rest. Source,
yeah,
destination.
destination.
So it's SCP space, source, space, destination. Does that answer your question?
Can you go up and try to do CD 2014? Because I think it should be a
2014
directory.
is not a directory. 2014 is a file name.
That's where I'm confused. But anyways, I'll ask
Well,
later in the class.
Tuesday is a file, so 2014 is a file. Yes, you have a question, go ahead.
So you're saying that the source in 29 there,
29, yes.
it's your name on that ECN computer, and you have the colon, and then what is the rest of that?
That's
where it is on that computer,
the
right?
path. Remember, you have many directories, and that's the directory where the file hello is stored.
It's coming from, not going
So
to.
if
Yes,
you put
and
space
how do I
and
do that?
period, it will just copy as it's Tuesday.
Which one?
In the 31, if you put space and then dot.
Which one?
31. Instead of 2014, if you put space and then period, you know?
You cannot.
You cannot?
You cannot have space here. You cannot have a space before 2014. That
So
means
then-
you are going to create a directory with a space in the name of you are going to create a file name with a space. File name cannot have space. So SCP has only two things: source, space, destination.
So instead of 2014, if I put period, it will copy the name as it is, Tuesday?
I think so.
Using period. I mean,
Okay.
I'm trying to use period there.
So I have not tried, just see. It's going to take a bit time to propagate the file.
You might need to go out of the directory first.
Oh, to refresh?
Yeah.
Yeah.
Okay.
Okay, does that answer your question?
Yeah, thank you.
Okay, so if I use period, that means a directory. Yes, thank you. So does that answer the question? You need to move files around. I know this is a very long answer to your question. How to move files around? If you want to use Windows, you use Secure CRT. If you want to use Linux, use SCP. And then if you want to log into a computer, use SSH. And if you want to open the window back from remote, like this way, you need to use -Y, capital Y. I still have 2 minutes. Actually, what I want to show you is the code stack. So let me try to do that. Okay, so I say GDB P01. So let me see what the function I should do. So suppose I want to stop at the function array sum, so I will say GDB B means breakpoint, means when the program reaches that place, the program will stop. So I set the breakpoint at this function. How do you know what to do? You look at this page. Here says breakpoint in the middle. I set the breakpoint at this function. Then I say run. R means run the program. The program will stop at this function. Then I can say BT. That shows the call stack. The main function is at the bottom, as somebody asked. The main function is at the bottom. This function calls this function, this function calls this function, and this function calls array sum. Yes?
The breakpoint is placed at the end of array sum.
The breakpoint is placed at the very beginning of the function. So if you do this, if you see, it starts at line 6. Right? Line 6 is the first line of the function. It has not run at line 6 yet. It's about to run line 6. It will be the beginning before anything else, anything inside the function happens. Okay, to summarize, today we talk about call stack. There are 2 rules about call stack. What are the 2 rules?
First in, last out.
First in, last out, that's what stack means. And what about call stack? Yes, please.
There are no exceptions.
No exceptions? What are the rules? Yes, please.
The line after it finishes.
When you call a function, you push the line after the function call. One more.
We can say that.
When the function is called, like the function popped.
Okay, when the function finishes, the top frame gets popped. Okay? Alright. I will see you on Thursday.
Can I ask a question?
Yes,
The
please.
call stack here, is it the call stack after the program stops working?
No,
Or is that like it shows the whole how it went?
no, the program currently stopped at the first line of the function. The program is still running. It just stopped because you want to see. So the program is ready to run this line. It stopped here because we asked it to stop.
Where did you ask it to stop?
I say B. Look at GDB. B array sum. I say stop there.